Hey everyone, and welcome back to a new coding adventure. This time, we'll be taking a look at the game GeoGuessr. Now imagine being dropped in this random location in the world. Would you ever know where you are? I'm trying to look for clues, but I can only see trees and an empty road. I mean, this vegetation makes me think it's Europe. But then I see red on the side of the roads, which almost resembles Kenya. But I mean, this can't possibly be Africa, can it? So my only hope is to go towards civilization and look for signs. And then I see a Montenegro sign, which obviously means it's Montenegro. Now, all I need to do is find it on the map and sit back and relax as I see the other players in the lobby desperately trying to guess countries all over the world. This actually led me to the fastest win on GeoGuessr ever, as I won in the first round thanks to finding the sign, which is probably less likely than finding a needle in a haystack. Now this made me wonder, wouldn't a bot be able to guess the country based on the landscape and vegetation? Okay, so to make the bot I'll need to download Street View images from the web of different countries, such as this Viking image from Norway, and then feed it into the neural network such that it is able to predict where the image is from. Sounds easy enough. Now to get our data we'll head over to the Street View static API from Google, which allows us to download Street View images for a given location in a country. So all we need to do then to get our data is generate random latitude and longitude coordinates for a given position in a country, and then download the corresponding Street View image from there. This can be written into code from a download image function, which generates random latitude and longitude coordinates for a given country. However, it is not always given that the random location will be in Google Images, as we allow for a maximum number of API requests per country. We then send these parameters into the Google API and wait for an OK status, which means we've gotten an image. We save these images to disk and continue downloading more images for different countries. Now, to get access to these images, remember to activate your Street View static API key in the Google Cloud Platform. This will give you an API key which will enable you to download Street View images from Google Maps. So here we have all of our training data, and if we look at Italy for example, we see all of the downloaded Street View images of Italy. We are hoping that our bot will be able to tell that we are currently in Italy. Now if we compare these to our images in the UAE for example, we can clearly see that the landscape is completely different, and hopefully our model will pick that up as well. So let us pick a model that will enable us to do just that. Our plan is to simply take a pre-trained model from TensorFlow, and then attach a small module on top of that to classify which country the image is from. Then this will allow us to use a model that has already been trained on millions of images, and then fine-tune it to adapt to our needs. This can be written in a few lines of code. We start by downloading a pre-trained model from TensorFlow called Exception. The model is trained on the ImageNet dataset, which consists of over 100,000 images. We set the trainable flag to false, as we'll use this as our frozen base model. We also add some random transformations to our dataset, as this will give more variety to our training images. On top of our frozen model, we then add some basic convolutional layers. Together with batch normalization and value activation functions, we then get the non-linearities we need to train our custom part of the model. Finally, we add a small classifier on top of our base model, which will then tell us which country the image belongs to. Then, all we need to do is compile our model with our Adam optimizer, and we use the sparse categorical cross-entropy loss function, as this is the standard loss function for classification algorithms. To finally train the model, we head over to the Google Cloud Platform, where after activating the Compute Engine API, we can set up a virtual machine with a GPU of our choice. We move the code and dataset onto the GPU, and after a day of intense training, it is ready to be tested. To get predictions from our model as we play a GeoGuessr round, we need to feed the images of our screen. We select this portion of the screen as it has no overlay text and has square dimensions, which is what the model has been trained on. I achieved this through this fairly ugly and hard-coded function here, But as long as it does the job, I'm fine with it. And now, with everything finally set up, let's jump into a GeoGuessr game and test it out. Being a big model, it runs at about 1 frame per second, and so we're getting approximately 1 prediction every second. Now, my first impression is that this is complete rubbish. It seems to change the country every time I take a small step. Not to mention the fact that it becomes 100% confident of a completely different country, when most of the image is actually the same as the previous frame. Living in Norway, I realized that this must be it. And I see that it actually has predicted Norway a couple of times here. So at least we know that it's understood something. Now, as I play through the second round of this Battle Royale, all of my confidence from the first round fades away. I mean, it changes the country for each frame and it just seems to be all over the place. However, for the most part, it does seem to pick the greenish countries in Europe. So it has some vague understanding of where it is at least. Right now, I would say it's got about an IQ of about a 6-year-old. It sometimes guesses the right answer, but for the most part, it's just complete random guesses. I need to retrain the model, as this is certainly not good enough. I reduced the number of countries from 195 to 50. As not all countries are used in the GeoGuessr Battle Royale. Also, I'm going to be looking at the predictions here in the terminal window quite a lot. So I decided to add some nice coloring to the model output, so that it becomes a bit easier on the eye. After training the model on a more narrow set of countries, I can see a noticeable difference right from the start. As you can see, the predictions are way more stable, in the sense that they don't jump around so much from frame to frame. And looking at only the predictions in green, which are the high confidence ones, there seems to be a more correspondence between the vegetation and landscape and the model's guess. However, as I spend hours debugging and trying to find ways to improve this model, I gradually become better at the game and realize that I don't really need a model to predict every single possible country. I just need a model that helps me with the corner cases and the obscure countries in Eastern Europe and Southern Asia that are quite hard to differentiate from one another. So, I opted to use an additional computer vision tool called optical character recognition, which is also an AI method to read characters from images. This will allow me to automatically tell which language text in image is written in. Since optical character recognition is also a machine learning model, I don't consider this to be cheating. And with the OCR completely implemented with this function here, let's jump into our final game. Alright, and let's jump in our Battle Royale game with everything set up. We've got both the model and the OCR reading. Now this is looking a bit Northern European-ish. We're getting Finland as a guess, Netherlands, Finland. Perhaps it's a bit too sunny for Finland, but certainly looking very Eastern European-ish. Oh, and this is very distinctive text. See, Romanian and Russian could be one of those two. Let's try Romania first, but it's not Romania. I mean, now I'm getting Russia, and the model has guessed Russia as well. So surely it must be Russian, right? What's this tag? Yeah, it's Russian. It's gotta be Russia. Let's guess that. And yes, it is. Well, I mean, perfect example of OCR reading and working extremely well. It did also guess Russia there based on the landscape. So I suppose taking those two into account, it had very high confidence in Russia. So very happy with that round. And with that, let's jump in our second round. Alright, it seems like there's only 6 players left. Quite a few didn't make that past round, but now This is also looking very European. In fact, I'm getting Belgium, Austria quite a lot, Slovenia, Czech Republic. It's certainly understood to sort of the general landscape of different areas, that's for sure. Quite strong guesses now in Czech Republic. I would say that's probably the highest, the most likely country so far. Got some high guesses for Austria as well. Oh, and there's snow suddenly. And in fact, it's starting guessing Finland because of that. But so far I would certainly say Czech Republic is the most likely guess. And here we got sign. Let's see which language that's written in. Oh, Czech Republic. Yeah, it must surely be Czech. We've got so many hints, both from the model and text reading. And I think we're in the final. Ooh, looking a lot more southern, that's for sure. Let's see what it's suggesting. Botswana. I mean, it could be in Africa, but that's Spanish, as we're guessing, and it's Chile. Must be. Oh, but he saw it too. And so, even though we lost the final by 1 second, we saw how we could combine a deep learning model together with a more classical computer vision technique known as character recognition to create a really powerful AI, which could maybe even compete against the very greats like GeoGuessr. But that's it for now, as I'm scared it might get too good and I'll be banned. See you in my next coding adventure.